All right, we're going to do a finite difference problem using this set of points, okay? And we said as long as your x are consecutive, this can work. So really my f of 1, f of 2, f of 3, f of 4, f of 5. 1, 3, 6, 10, 15. Take the first level differences. 2, 3, 4, 5. That's your first level, right? Take your second level. 1, 1, 1. Guess what? My second level differences are the same. That means I have a quadratic equation. So what's the general form of a quadratic equation? Y equals ax squared plus bx plus c, where a, b, and c are my unknowns. 3 unknowns means I need to use 3 equations. And I'm going to use these points for the equations, because that's what I do. Now actually I am going to rewrite this so that it's equal to y, because that's how we'll end up putting it into the calculator. So the first point says that a times 1 squared plus b times 1 plus c equals 1. The second equation says a times 2 squared plus b times 2 plus c equals 3. The third equation says a times 3 squared plus b times 3 plus c equals 6. So we are going to build ourselves a matrix with the coefficients, right? And the coefficient in front of these c's are all 1. And I'm going to have the answer in there. So 1 squared is 1, 2 squared, 3 squared, 1, 2, 3, 1, 1, 1. And this fourth column will actually be what I call the answers. I'm going to show you a really nifty way on the calculator to solve these. So you're going to input this particular matrix in the calculator. I'm going to go to second matrix. I'm going to edit and build myself a 3 times 4, right? So build a 3 times 4. Then I'm going to put in 1, 1, 1, 1, 4, 2, 1, 3, 9, 3, 1, 6. I think I have those in there. This is what it looks like. It is a 3 by 4, isn't it? So I will quit out of that so I can see my screen. And then with that matrix, I go to second matrix. And I'm going to go to the math column. I go over 1 to the math. And I'm going to go down to letter B says RREF. Hit enter, and that brings that to the front screen. Then you're going to go back and pick the matrix you want. So I'm going to hit second matrix. Under names, under the names column, I'll pick my A. That's where I have my 3 by 4. So now on my screen it says RREF A. And I'm going to close my parentheses and hit enter. And this is going to do all sorts of manipulations so that the answer is 100.5, 010.5, 0010. What does this remind us of? This is the identity matrix, okay? And these happen to be our answers. A equals 0.5, B equals 0.5, C equals 0. Plug those back. If I go back here, take my original equation, plug those in. Well, y equals 0.5 x squared plus 0.5, 0.5 x plus c, which is 0. This equation gave us those points. All right? Let's try another one. Let's go back to the one we started in class. I'm looking for the list. Right here we had here. Okay. So I'm going to use 0.11, 2, 4, 3, 10, 4, 20, 5, 35, 6, 56, 7, 84. Going to list the y's, right? I want the f of 1, f of 2, and so on. So this is 1, 4, 10, 20, 35, 56, 84. All right, first level differences. 3, 6, 10, 15, 21. Trying to make sure I don't make a mistake. 28. So these are the first level, right? They aren't the same. Second level. 3, 4, 5, 6, 7. Second level are not the same. 1, 1, 1, 1. All right. Third level differences are the same. If the third level differences are the same, my standard equation has to be in the form of a cubic, doesn't it? Let's get rid of that. So it'll be ax to the third plus bx squared plus cx plus d equals y. Now, using the points we have 1, 2, 3, 4 unknowns. I have to use 4 points. I'm going to use 1, 1, 2, 2, 4, 3, 10, 4, 20. Okay, first I plug 1 in. A, 1 to the third, plus b, 1 squared, plus c times 1, plus d equals 1. A, 2 to the third, plus b, 2 squared, plus c, 2, plus d equals 4. A, 3 squared, 3 to the third, plus b, 3 squared, plus c times 3, plus d equals 10. A, 4 to the third, plus b, 4 squared, plus c times 4, plus d equals 20. And the coefficients in front of d are all 1. So this matrix we write is the coefficient matrix plus the column of answers here, right? So we have 1, 8, 27, 4 times 4 times 4, 64. Now the squared column, 1, 4, 9, 16. 1, 2, 3, 4, and my answer column is 1, 4, 10, 20. Right? This one's a little bit bigger. Oops, did I miss I missed a column, didn't I, folks? I forgot the D column, which are all 1s. 1, 1, 1, 1, and then 1, 4, 10, 20. So this is a 4 by 5 matrix. So I'm going to go to my matrices under Edit and put in a 4 by 5 matrix. Fill it across. So 8, 4, 2, 1, 4, 27, 9, 3, 1, 10, 64, 16, 4, 1, 20. All right, so I have filled this in. This is my matrix A. So I'm going to go to second matrix, go over to the math column, which is the second one, and find RREF. First, actually, I should quit out of everything, so I'm at what I call my front screen. Then I do second matrix, go over to the math column, go down to B, which is that RREF. It brings up to the screen RREF, like that, with an open parentheses. Then I hit second matrix, stay under the names column, and hit A, close my parentheses, hit enter. So my answers are, I will have the identity matrix here, won't I? On this side. And then my answers are, and I think I want them in fractions, because I like fractions, 1/6, 1/2, 1/3, and 0. All right, so what does that look like? I'm going to go to the next page. If A equals 1/6, B equals 1/2, C equals 1/3, D equals 0. That would be ax cubed plus bx squared plus cx plus d, don't really need to write that, equals y. Right? This is actually example 3 on page 395. So based on those two examples, we can try a few of these and see if we can get an answer. All right? I want you to try on page 397, 19, and 21. I think that's a good one to try. I think we want to try those two. They do have some different polynomials. So you will use finite differences to figure out what order, right? It'll tell you what order your polynomial is. Okay, so give those a try. Thanks.